Let's talk about lithium polymer batteries. Firstly, we will talk about what is lithium polymer battery. Secondly, safety guidelines. And lastly, how to choose correctly lithium polymer battery. What is lithium polymer battery? A lithium polymer battery, or more correctly, lithium-ion polymer battery, abbreviated as LiPo, LiPoly, lithium poly and others, is a rechargeable battery of lithium-ion technology using a polymer electrolyte instead of a liquid electrolyte. Highly conductive semi-solid as gel polymers form this electrolyte. The main advantage of LiPo batteries is that they have a much higher discharge rate than NiMH and NiCad batteries, meaning that they can be discharged and recharged multiple times without losing their power. They are also relatively cheap to buy and maintain compared to NiMH and NiCad batteries. Batteries are the first practical way of generating electricity and were invented by Alessandro Volta. Before generators came into the scene, batteries were the main source of electricity till the end of the ancient electric cars also used the semi-sealed wet cells. This background of the batteries was the key for the development of the LiPo cells. The discovery of the lithium polymer battery cells came because of the lithium-ion and lithium metal cells as they went to depth in the 1980s. A significant yet remarkable milestone was the first commercial Li-ion cell of Sony in 1991. There was a revolution thereafter which introduced a pouch form of battery called LiPo. Design, organ and terminology. Lithium polymer cells have evolved from lithium-ion and lithium metal batteries. The primary difference is that instead of using a liquid lithium salt electrolyte held in an organic solvent such as ECDMC-DEC, the battery uses a solid polymer electrolyte such as polyethylene oxide. A typical cell has four main components: positive electrode, negative electrode, separator and electrode. The separator itself may be a polymer, such as a microporous film of polypropylene. Thus, even when the cell has a liquid electrolyte, it will still contain a polymer component. In addition to this, the positive electrode can be further divided into three parts: the lithium transition metal oxide, a conductive additive, and a polymer binder of polyvinylidene fluoride. The negative electrode material may have the same three parts, only with carbon replacing the lithium metal oxide. The main difference between lithium-ion polymer cells and lithium-ion cells is the physical phase of the electrolyte, such that LiPo cells use dry, solid, gel-like electrolytes, whereas Li-ion cells use liquid electrolytes. A lithium-ion battery, also known as the Li-ion battery, is a type of secondary, rechargeable battery composed of cells in which lithium ions move from the anode through an electrolyte to the cathode during discharge and back when charging. The cathode is made of a composite material and defines the name of the Li-ion battery cell. The anode is usually made out of porous lithiated graphite. The electrolyte can be liquid, polymer, or solid. The separator is porous to enable the transport of lithium ions and prevents the cell from short-circuiting and thermal runaway. Chemistry, performance, cost, and safety characteristics vary across types of lithium-ion batteries. Handheld electronics mostly use lithium polymer batteries, with a polymer gel as electrolyte, a lithium cobalt oxide, LiCoO2, cathode material, and a graphite anode, which offer high energy density. Li-ion batteries, in general, have a high energy density, no memory effect, and low self-discharge. One of the most common types of cells is 18650 battery, which is used in many laptop computer batteries, cordless power tools, certain electric cars, electric kick scooters, most e-bikes, portable power banks, and LED flashlights. The nominal voltage is 3.7 V. Note that non-rechargeable primary lithium batteries, like lithium button cells, CR2032, 3V, must be distinguished from secondary lithium-ion or lithium polymer, which are rechargeable batteries. Primary lithium batteries contain metallic lithium, which lithium-ion batteries do not. General safety guidelines. Never use a NICDE NIMH charger to charge LiPo batteries. Only use chargers designed for lithium polymer, Lipo batteries. Never store LiPo batteries in any location that exceeds 40 to 80 degrees F, e.g. in a car, garage or in the sun. Never leave charging batteries unattended. Keep watch on the charging process and react to any potential problems that may occur. Never let the battery's positive and negative leads to touch. This can cause the battery to short and lead to a fire. If, for any reason, you need to cut the terminal wires, it will be necessary to cut each wire separately to make sure the wires do not touch each other. Always charge batteries in a fireproof container and away from combustible material. Do not charge on surfaces that can catch fire. This includes wood, cloth, carpet, or in the application's device. Always inspect the battery to make sure there are no signs of damage, deformity, or swelling before charging. If there are, stop charging the battery and follow the proper procedure to dispose of the battery. Never charge a swollen or ballooned or damaged battery, even if swollen upon purchase. Continuing to charge a battery that has begun to swell will result in a fire. How to recharge a Lipo battery. It is recommended to recharge the battery well before it drops below 3.0 volt. If the battery must be stored for a long time, it is a good practice to charge them to about 3.8 V, where the self-discharge rate is low, and periodically monitor the voltage to make sure that it doesn't decrease below 3.0 V. How to discharge a Lipo battery. Lipo batteries are widely used in various applications, from drones and RC cars to portable electronics and more. Proper handling and maintenance of these batteries are crucial to ensure safety and longevity. One important aspect of Lipo battery maintenance is discharging. Lipo batteries should never be discharged below 3.0 VRSL or it may permanently damage them. Many chargers don't even allow you to charge a Lipo battery below 2.5 VXL. How to choose a lithium polymer battery for RC drone. 1. Find out how much current your drone can draw first. Choose the engines based on their thrust. You can calculate the total current drawn by the motor. There are other parts that use power from the same battery, such as flight controllers, RC receiver, LED, FPV, etc. Very little compared to powerful motors, so we can add 1A to 2A to the total current draw. 2. Decide on the battery size. Battery size is an important parameter for a greater flying experience. Always choose the battery with more capacity to be able to serve your drone for a longer period of time. The ability of a Lipo battery to provide maximum flight time in the air depends on the excess weight of the drone. 3. Battery voltage. Battery voltage, or number of cells, is an important parameter. Motors with a higher voltage rating will produce higher power RPM. Batteries with higher voltage ratings have more weight. When choosing a battery voltage, make sure that your motor's ESC and other electronics can support the voltage of your battery. You'll need to choose the best one for your current setup based on the total number of motors you're using. 4. Battery C rating. The degree of discharge is an important parameter of a Lipo. The exact performance of your drone depends on the discharge C rating. Professionally, we recommend choosing batteries with a maximum C discharge rating. Normally, the high discharge rate of the Lipo battery has more weight. It will definitely increase the overall weight of your drone. As a result, the full flight time of your drone is shortened. 5. Battery capacity. First of all, choose the highest capacity battery that can provide longer flight time. When choosing a new battery for your RC drone, always opt to choose a size based on the specifications of your device. Its weight should not exceed the range that your drone cannot lift. 6. Battery connectors. There are two types of connectors used in Lipo battery. The main connector is one power connector, and the other is the balance connector. Only 1S batteries have one main cable. There are a variety of different types of connectors that vary in size, current rating, and ease of use. If two male pins of a battery stick out, there is a chance that they will bend and short-circuit together. For safety reasons, the LiPo always uses female connector in the PIDE.